Hello folks, welcome back to the another episode. Today we're gonna see Kubernetes networking, that means in OpenShift as well. So I will explain very simply and crispily. So I will be try to, and because it's a deep topic. So everywhere it's networking. If we going for internet, it's a networking. If we touching any servers, there will be a backend service. Most of things um, will based on the communication. So those are the very important things in cluster in Kubernetes. That also, if we troubleshooting something, we should know a minimum knowledge of this networking. Um, so if you guys are worked in background of networking, no CCNA, no IP protocol on this OSP layer models and everything, it will be very simple, like what I'm saying, this concepts at all. If you're new to OpenShift, this course is a beginner course only, but however you should know or aware about this services and IP addresses and subnets. These are all very important. So then we can easily understand how these pods are communicating, what are the services and how they are exposed, and how we from the company, the corporate companies are launching a lot of websites, applications, Uber, Zomato, Swiggy, and whatever. So games, whatever, everything will run in background in a cluster, in a server. That means in a server. So previously those will run in a servers. So those have developed and uh, they released the latest. At last, a huge server came into the VM, and VM went a nano server, and nano server went now as a pod and container, right? So this is the concept. Like it's a basic concept. If you want to understand what is the um, what's going on, how this paths, containers, what kind of concept means. You want to know a lot means just comment it. Let me come with different slides. Like I will elaborate them with PPT slides, whatever, right? So I'll try to deliver as much as okay. So today, these four things, I can't particularly mention anything. Networking, so that is a CNI networking. This is the concept. Okay, so I got a good blog from this K21 Academy. So they given a good article. So these are the things. That's it. This is the networking. So this, if you working in application side, you're gonna use this. If you going to troubleshoot in the administrator side, you should aware about how these are communicating pod to pod, pod to services, service to ingresses, ingresses to the outside the organization or whatever, how they exposing through the load balancer. Okay, right? How they controlling the traffics and what are the layers. And at last we will see routes and the load balancer, right? So usually you guys want to know minimum about the Kubernetes, then it will easy to understand. So first, if not, so I will explain very easy and crispily. Okay, right? Very simple method, right? So these things, if you know, just observe it and you go through this article. It's very simply he explained, uh, so you can understand. Yeah, and I will explain that. And these are the only the networks you're gonna use in the cluster. Apart from that, you won't use much. And for service mesh, there is an Istio that also will work in the same ingress method. Okay, that I will come for that, right? Okay, we'll go for that. Okay, first let me explain it. What is the networking in Kubernetes? So Kubernetes or OpenShift, both are same, and but in OpenShift they are automated. Okay, fine. In Kubernetes, if we want a networking inside the cluster, we want to install a CNI plugins. Okay, CNI plugins will be like open source projects of some other community. Okay, for example, uh, Funnel and Calico and Cilium. Those are other open source projects, so nowadays available. There will be available in the different websites. We can take that as a Kubernetes administrator. They will install in the clusters when it going for the production. But in OpenShift, it's not required. It's everything by default. It will come, right? So in older version, SDN used. Now OVN Kubernetes used. I will show you in the cluster. Okay. So first networking. Networking are the mandatory thing in the Kubernetes. So Kubernetes networking allows Kubernetes compound like pods, container, API, server, etcd cluster, scheduler, whatever they want to communicate inside. Networking is a backbone. To communicate each other, there should be a different components will be there. So but the communication will be through the flow, packet flow like that. Okay, right. So first, once we install the network operator or plugins inside the Kubernetes, so then we can do the deployments and everything. Okay, once they provision the cluster, they will install the network components also, like CNI plugins into Kubernetes. In OpenShift, they will go for the OVN by default, right? So what it will do first, a pod application team. Okay, cluster is provisioned, CNI plugins or operators are installed. Now what the stuff, what we gonna do? Our application team is going to deploy a deployment, right? So a deployment will deploy one or two replica. Okay, a deployment nothing but a replica sets. So with a stateless application, okay, a deployment will communicate with the replica controller. Replica controller will do the replica sets, 2, 3, 4. How many parts you want? You want to uh, uh, configure in the deployment, and it will deploy the pods. Okay, now it deployed the pods in the cluster. Okay, 4 pods are running. Okay, how we will communicate, how we can check the application is exact web page is showing or not. These things we want to check, right? So for that, this operator, once we deploy the CNI, once we deploy the pod, this will get the automatically IP from the CNI. Okay, CNI will assign the cluster IP to the pod. So basically it will assign the cluster IP, so nothing else. Okay, we can see here. So once you deploy the nginx pod, so it will get the cluster IP, okay, by default. This is the first step of the networking. Initially once pod is deployed, every pod will get the cluster IP, right? Okay, okay, it got the cluster IP. So what the use of this? Okay, once it got the cluster IP, okay, now you can curl that pod inside that cluster, and you can check the files whatever. You can do SSH, like not SSH. You can get into the pod and you can check the files whatever, and you can uh, send the traffic or receive the traffic. So such things. Okay, so what it will do? Uh, so first a pod will have the container. Okay, and those containers, those containers will have the particular port number. With the port number only, those will communicate, right? So pod and pod port number, right? Inside the container will have the port number, and outside the pod, it will have the target port number. Okay, and it will go for the service, and it will go for the outside the world. Okay, this is the uh, like minimum concept. Okay, so now, so what it will do? Container to container communication, IP address required. Pod to pod communication, IP address required. Pod to the another node. 4 pods are there. 4 worker nodes are there. One pod want to communicate with another in the fourth worker node pod. It should require an IP address, right? So those will by default it will allow to communicate inside the cluster. There is no restriction for the IP address until unless we will restrict with the network policies, right? Or isolate the namespaces. Okay, those concepts you we will see after some time. Like, okay, pod to communication, pod to pod. or part 2 services. For those concepts, we require the IP address. Okay. Now cluster IP, we came to know. Cluster IP inside the node only, inside the cluster only, we can access the pod. For the purpose only cluster IP is there. Okay, we'll see. So now we can see basically. So first we check the operator like CNA plugin. Okay. So in Kubernetes, we want to install, it will run in the kube system namespace only. You can see CNA plugin, Calico, whatever in the same kube system. But in OpenShift, there is in a separate namespace, OpenShift network operator, and there is a deployment with the name of network operator. Okay. So we're getting the network operator. Let me describe this. We can see. This is, this is the challenge sometimes I'm facing. Right? So it's described what we're getting now. See, operator or CNA plugin will have some parameters. Okay. In the spec, we can see cluster network. Everything will have the CIDR. For the pod, for cluster IP, it will have a subnet of 10.217 series of IPs it will assign. Right? 0.0. That means approximately like above thousands. I know that. Okay. So it having a huge number of IPs it can able to assign. Okay. So in this cluster it can assign a huge number of pods with this subnet. So we want to check the subnets. Or in Kubernetes we can if we want we can customize this based on the cluster. Okay. This cluster IP will get the IPs from the CIDR of this cluster network. Okay. Then so okay, if we want to expose a hundreds thousand of paths with the cluster IP, we can't expose that application. So each pod will run as a application. So if a user is hitting the uh, application Nginx, 10 user can access this Nginx. Means we require a load balancer, so it will come to the directly to the node port. Like yeah. So okay, now we will involve the node port. Okay. Right now we don't have the service. We consider the we don't have the services. Okay. We have this 3 Nginx pods and each will handle 10 user traffic. Okay. So this 10 user traffic will come like that means 3, right? 30 user traffic will come to the load balancer, directly come to the pods. So it can't handle that many traffics, right? So what they did, uh, they created a service. So they mapped all the spots to the service. So once, okay, this will have the cluster IPs. Each pod will have the cluster IPs. These uh, IPs are binded with this services with the endpoints. So this now, as per this service, these are the endpoints now. Okay, it will come to the node port and it will come to the services and it will redirect to this endpoints. Okay, now hope you guys are will get. Okay, if any queries, comment it. It's that simple. Cluster IP, now everything binded and put it in the box, and there is only one pointer there. If any front end traffic is coming, it will direct to this services and it will redirect to that boxes. Okay, whichever pod are free, it will share to that pods. Okay, that's it. It's a simple. Okay, next. Okay, traffic came inside the load balancer and came into the cluster node port. Node port in the sense um, a worker node. Okay, a worker node will be there. Okay, node port is very simple. In the cluster, multiple worker nodes will run. Okay, in which worker node the pod is running, we can access that pod through that worker node IP and with the port number. So which we mentioned in the deployment. If we give that uh, IP type in the deployment, node port means, so we can directly put that IP and we can access the um pod inside the node port. Okay, right, that's it. So node port is nothing inside the cluster. Using cluster IP we can access that application. Outside the cluster, that means inside the organization, with the node port we can access the applications. If I'm sitting here, my server is running inside the, like it's running in the mm, mm, cloud. Okay, we connected with the VPC. Okay, I can log in that utility, bash and host, whatever, and if I do curl with that worker node, 10 worker nodes are running, and with that particular IP and with that port number which we given in the deployment, we do the curl and we can access the application. Okay, without logging into the bash and host with your laptop if it's connected with the VPC. Okay, or rather, if it's in cluster IP, you want to log in the bash and host. Okay, and you want to curl that. That's it. Okay. Now we go for the load balancer. Okay. Let me explain one more thing. Okay. This is the node port concept. Okay. Next, there is one more thing. Yeah, two things are done: cluster IP, node port. So if you want, you can do kubernetes.io. There will be a huge explanations, so you can get more idea. So load balancer, it's very important. Okay. This is the right now traditional culture. It's going this in this way only. We are accessing everything. You having a Swiggy app and you are ordering something, the traffic will go to the company server like load balancer, okay, or firewall. So it will go there and it will pass to the, in between, ingress will be there. Okay, Istio service mesh or ingress will be there. Okay, those will get, because in our application a lot of modules will be there. For example, home. So for this website, we having a home, blog, service, product, solution, boot camp, everything is there, right? So everything will run in the different pods, right? And everything will run if for home is there, blog is there, service is there. So I'm saying this as an example. Okay, it's a features. Okay, this will run in the 10 pods. This will run in the 10 pods. 10, 10, 10. Okay, everything is running in 10, and 10 pods we can access, right, with the cluster IP. Now we creating a service. 10 pods will bind with the one service. So now this 50 pods running with the 5 services, correct? So now the 5 services can't bind with the load balancer. Okay. Then if we have thousands of different modules and we can't bind that in the load balancer, so what they will do, they will create 1,000 services and they will map with the ingress. Okay, that concept came here. Okay, load balancer and services. So it will be a head pain if 1,000 services are there and 1,000 pods, 1 lakh pods or 2 lakh pods are running, they can't handle it. So in that aspects, the ingress came into the picture. Okay, ingress controller. Okay, usually what it will do, once we receive the traffic in the ingress, there will be a set of rules and path will be there. So it will hit that path and it will redirect to that services. Okay, 100 rules will be there, and for which, for example, home dot, if this is the site and if the Kubernetes network, if this is the this Kubernetes network is a one services, so it will bind it in with a particular rule. If I'm going this page, it will redirect to that service. That ingress will find out the host path, and it will redirect to that service, and it will redirect to that paths. Okay, if I'm going to the different this one a different page, and it will redirect to that site, and it will redirect to that services inside the cluster, and it will go for that paths. Okay, for each of this is the host, like domain. Okay, these are subdomains. These subdomains we can't afford. Okay, the for that concept only ingress came. So every time .com, and for example Google having a google.com, and those their product only Gmail, their product only OneDrive, everything, like sorry, G Drive, right? For everything they can't get the multiple domains, so they will make the subdomains. Okay, you can see the slash path. Okay, so those will, once the slash defined, and it will go for the particular ingress service rule, and it will go for those paths. So those will see in the ingress. Okay, later. That's it. So those ingress will redirect the traffic to the particular services, and services will redirect to the pods. Okay, that's it. These are the concepts. In Kubernetes network, cluster IP, node port, load balancer, and there is in a Kubernetes DNS service discover that we will see on later session, and in OpenShift there is a concept, one more, routes, right? So what is route? OpenShift route. So OpenShift route is simple. It will do the load balancer job only. Okay. But if it's doing the load balance job, and what is the work of the load balancer in the OpenShift? Okay, we will get the question. Similar, I also got the question. Okay, I got this article. It's a logical, some logic is there. Okay, I can accept this too. If there is one application or one services, whatever, we can expose through the HTTPS ports, and we can do the TLS encryption, everything. And for one particular application we can expose, but for a multiple applications we require a load balancer, right? I'm sitting here, I can access the, once they expose the route, we can access. But for a multiple things we can expose with the routes, because it's required multiple CNAMEs we want to create, and those won't be a uh, convenient and professional way. Okay, so for already traditional way, a load balancer is there. We can use the HA proxy external load balancer, and that is what they have given the answer, right? Internet routes services directly point to the pods, right? Same, if we have internet mobile, and if you expose that service as a routes, and we can access it. But in load balancer, internet, and it will hit the load balancer, and it will segregate, and it will find out the rule in the ingress which service is mapped, and will redirect to that particular pod. Okay, right? Just Google it, you will get that. Okay, that's the main thing. I got a serious confusion yearly. Uh, just I'm giving explanation. That's it. And let me show you. Uh, for services also, those will get the IPs. Okay. Uh, see, services will map with the ingress with the IP or name, whatever. Okay. For services also, OVN will assign the a subnet of IPs. Okay. It's a 4.0. It will be a less. Pod will get a lot of IPs, but services will get less number of IPs, because mostly a huge number of services we won't create. A huge number of pods will run in multiple worker nodes, but services won't be like that, right? And this is the network type OVN Kubernetes. Okay, then okay, let me explain what concept I have explained in the practical. We'll see OC run nginx image nginx. Tada. Okay, so git pod c. It's creating. Still it didn't got any IP because it's still in creating process. Once it got created and it got the IP with the 10.217.0.subnet, right? So what we see in 0.subnet, it got from cluster network. Then we will create the service. So it will get from so by default Kubernetes will run some services. So you can see Kubernetes will have cluster IP and it will run some services. So one service, these are default services. This is local. If you can't ping or communicate with this Kubernetes default dot svc dot cluster dot cluster dot local, then something wrong with the DNS. Okay, for debugging we can confirm this. So we will create the services. OC expose service web server, right? Okay, expose svc name nginx pod pod. So before we want to create the pod, so, create the services. Okay, OC expose pod. What is the name? Nginx, right? Could not find port number. Okay, we'll define the port number. Port 80, right? OC get svc. So now we expose the nginx service. Okay, so we can curl and we can confirm this, but I can't do in this prompt. Okay, so it got from 5.series. Okay, right? So this is the series of IP. So it's getting from 5 dot. Yeah, that is, it's a 4 dot and it is a 5 dot. Yeah. So 4.2 255 and it will include both 4 dot to 255 and 5 dot 255. So totally 512 of IPs it can able to assign. Okay, and guess how many IPs can assign by this series of CIDR. Okay, comment it. Okay guys, it's exposed now. Nginx is running in the 80 port number. Okay, so let me expose this through the XML without the load balancer. We can expose this through the route. Okay, I have already this steps. Okay, okay, this is for this services we want to know how many endpoints are there, right? There is only one endpoint, nginx It's created by 4 minutes back, and it's running in a 80 port number. Okay, it's a just a individual power running uh, with the simply we have created with the imperative command. Okay, now we go for the declarative. We will create a deployment. Okay, it will easy to understand also. Usually it's a good practice, and that is what happening in the companies also. They will use to create the deployments. That's a way. And so we will do that through the console. We will deploy one deployment. Okay, in this default, or rather we'll go for workloads pods deployment, right? Pod deployment, we'll create a deployment name nginx rolling update. Okay, done, whatever. Okay, pull it from that. Environment variable key values, anything. Okay, we'll select the image. Is there any nginx? It's having nginx or not, I don't know. Let me create what? Nginx subdomain must consider lowercase. What a given. Oh god, a lot of hit pine. Okay, we'll go for the command line. Okay, yeah, unnecessarily we wanted to troubleshooting at all. Okay, I have the commands, we'll run them. Deployment name, web server will give it, and so it will also create. Okay, we'll remove OC delete pod nginx svc, right? We have cleared everything. Okay, we will create a deployment with the port number nginx web server. Okay, right? Okay, OC get deployment web server. It's running. Okay, we'll go and get the console and we'll check default. Okay, there is a, yeah, it's running. So what is deployment? Deployment is simple. It will create a replica sets, multiple paths, and how many we want. We can scale it up and scale down. See, there is only one pod will running. OC get pod -w watch, only one, right? And now we can see we will scale it up to 2. Resource container is creating, observe, nothing. Okay, I think it's running. So it's creating, pending, creating, running 7 seconds. Okay, yeah, it's running. So we'll go for one more pod. I like to do this, right? So it's creating, right? Okay, let me uh, reduce that. See, we can see in the YAML, it's a deployment YAML, right? Where is the deployment? Yeah. So in the inventory, you can go for deployment, click the deployment, see the YAML. Now we scaled it to 3 replicas. Replica sets, there is one replica set, it having 3 pods. Label app is equal to web server. With that label, we can get them. So how this replica sets are and deployments managing these pods under in different Orca nodes or namespaces, how they are identifying this is the pod to related to this deployment, how they are matching. So everything is key values. label. So in Kubernetes or OpenShift, everything resources are identified with the labels and selectors. The selectors will go for the controller, and the labels, that means values, whatever, the labels will labeled on the multiple which resources are running, right? Identical resources. So identical resource in the sense multiple paths, multiple worker nodes, multiple services. Yeah, right. Um, what else? These kind of things at all to map particular part to the particular node. We will use the labels. So over in the pod and the selector over with the deployment or controller, whatever, right? So these concepts are um, differing the selectors and the labels. Okay, right? Fine. Okay, we will reduce to the single now. Single pod. Okay, see it will complete and it's terminating. Right. Okay, we'll go with the two parts and quickly we'll finish this. So it's been 36 minutes. Right. Okay. Let me explore expose the services. Expose SVC. Deployment. Slash. Right. OC get. Okay, web server is running. OC get. How many pods? End. It will come. No. We want to type completely with endpoints. So web server contains two pods, right? Two pods are running in the under this web server deployment. Okay, and it's connected with the service right now. So web server having 5 dot and this pod's having a cluster IP. Okay, and now so we will expose the services as a route. Okay, we're gonna see that. So now we create the deployment, we create the services, and at last a user want to access, right? So for the purpose we will create the route. OC expose with the web server route. Okay, right. Right, we have exposed OC get route. See, this is the route host running the port 80, services mapped with web server. This is the name of the route, and we copy this and we'll go for the browser, and if my time is good we can access or we can't. Tada. Yeah, we can able to access the nginx pod which we are running. The nginx pods, multiple pods, and if we hit the continuously traffic to this pod and it will replica. If we give that condition in the deployment, it will create a multiple pods, or rather they will hang, or it will go for the crash, right? Right. So today we have explained the concepts. We observe the concepts of the networking services and instant of the load balancer. So if the cluster is running with the public IP, and we can able to access this routes in our mobile also, in our like in our laptop, wherever, if it's running in a corporate organization, and if you expose that as a route, and it will assign this um, C name from the domain record, and we can able to access, right? That's it, guys. we'll see in another video. Okay, thank you.